Okay, so in this video, we're going to be talking about problems that are involving limits. We're just going to be solving limiting problems, and these are problems that I'm going to be solving using the equation we spoke about in the last video, where we had the equation the limit as h approaches 0 of f of x plus h minus f of x, all this over h. So we're going to be solving a couple of problems, but using this equation here. It's called the equation of first principles. And so let's look at this particular problem that we have here. So we have f of x is equals to x squared plus 5. Now, how do we go about solving this particular problem here? So what we can say is that we can first write what is our f of x. F of x is x squared plus 5, and then we need also our f of x plus h, and this is equals to, so what this basically means is that where we see x, we're going to substitute x plus h. So this is going to be x plus h squared plus 5. Now basically let's just solve this. What is x plus a? What is x plus h? It's x squared plus 2xh plus h squared, and then plus this 5. All right, so now we can just substitute that into place. So this will be equals to the limit. So another thing that you need to know is that you always need to write this limiting expression until you get to the limit itself. So as h approaches 0, as f of x, so this is x squared plus 2xh plus 2xh plus h squared plus 5. That's this 5, and then we have to subtract f of x, that's in bracket x squared plus 5. So this is basically going to be minus x squared minus 5. And the reason why I'm pointing that out is that I want you to realize that this x squared is going to cancel with this minus x squared, and this plus 5 is going to cancel with this minus 5. So what I'm actually going to be left with is just this part. So what I'm going to get here is the limit as h approaches 0 of 2xh plus h squared. So I forgot to mention, let me just put this down, because this limiting expression is supposed to be over h. So this is going to be over h, and this is now equal to, now remember, like, we can factorize the top, so we can actually factorize this actually up to h 2x plus h over h, and then this h will cancel with that h, and I'm actually just left with 2x plus h. So this is now 2x plus h, the limit as h approaches 0 of 2x plus h. Now here is this last step. I explained this last time when I said that in the previous video, where we said that h is going to approach 0 anyway, so it's just going to fall apart because it's insignificant or it's negligible. So we can just say this is equals to 2x. I want you to realize something here. So the next problem that I'm actually going to be solving is the graph of f of x. I need you to realize something. F of x is equals to x squared. And I'm going to be solving this graph here next. And the way to solve that, we put our equation together again. F of x is equals to x squared, and f of x plus h is equals to x squared plus 2xh plus h squared. Now what I'm trying to point out is, if I solve this graph, this is going to be the limit as h approaches 0. So this is supposed to be on one line anyway. I'm just using two lines because the whole thing won't fit on one line. So this is supposed to be on the same line. So this is now f of x plus h is x squared plus 2xh plus h squared, all this over h, and then minus x squared then this x squared will just cancel with this x squared, and then what I'm actually left with is the limit as h approaches 0 of 2xh plus 2h plus h squared over h. And then we can factor out the top, and then we'll cancel out with this h, the limit as h approaches 0. Then I'll be left with 2x actually plus h. Then we say that the h falls away, then this is equals to 2x. What I want you to, why did I write? Yeah, it's equal to, what I want you to realize is that this solution is equals to this solution, even though the graphs are different. This graph that I have is x squared, but the graph that I had here is x squared plus 5. What I'm trying to point out to is to say that this a constant, right? When you're dealing with a constant like this particular problem, the constant falls away. When we find the gradient formula, the constant always falls away, and then what we just left with is a solution that never had a constant to begin with. So I just want to point that out. And the reason why that is, right, if we look at these two graphs, if I say that this is x plus 5 and it's starting here and it's going up to infinity, and this is also going up to infinity, but it's starting at 0, there's no difference between the gradients of these two graphs. What's the only different thing is where they're starting. That's why the constant doesn't matter, because as you know that the constant in this particular graph, the parabola, just shifts up. The constant is the value c, which is also the value of q. It just moves the graph up and down on the y-axis. And in this particular case, you can see that it really doesn't affect the gradient of the graph. Now, how about this particular graph that has no constant, but it has another variable? So in this particular case, we have x, and we have another variable, another term with a variable. And in this particular case, we repeat the same process that we've been looking at the whole time. So in this particular case, f of x is equals to 3x squared plus 4x. Now, f of x plus h, what is that going to be? So this is going to be equal to, I actually would like you to, if you have the time, to actually pause this video and try to solve these problems on your own, and actually replay the video after I'm done. So 3x squared, we know what x squared is going to be, so we can just say 3, and then x squared is going to be x, the x plus h, this is going to be x plus h squared plus 4x, but x is x plus h. And then we solve for this. Now we expand it. This is going to be a little bit long, so I might need some space. So this is going to be 3x squared plus x plus 2xh plus h squared plus 4x plus 4h. Okay, and then now here we can actually multiply the 3 into the bracket, so we can say 3 times x squared is 3x squared, 3 times 2xh is plus 6xh, and then 3 plus this is going to be 3h squared plus 4x plus 4h. So now we substitute this into our limiting formula. So this will be equals to the limit as h approaches 0, f of x plus h is this long expression here, which is 3x squared plus 6x h plus 3h squared plus 4x plus 4h minus the minus f of x, which happens to be 3x squared, and this will be in brackets plus 4x. However, when we take out the brackets, this minus sign is going to be distributed, and both of the terms will end up being a minus. All of this is over h. We write limit as h approaches 0. Oh, this is a terrible handwriting. Limit as h approaches 0 for this. So what the first thing here that we can note is that we can actually cancel some of these terms. 3x squared can cancel with the negative 3x squared, and I think 4x. Yeah, 4x with the minus 4x can cancel. And what I'm left with is 6xh plus 3h squared plus 4h. All this is over h. And what's beautiful about this is that we can actually factor out h because all the terms have an h in them. And this is 6 without the h is just 6x plus 3h2, no, one of the h's fall away, plus 4. And then the h will cancel because we're dividing h over h. And then now this is equals to, now as we've been saying, that all the terms that have h will fall away because h will approach 0 in this particular time. So we'll have 6x plus 4. So this video is already 10 minutes long. I think that's it for this video. And before I say thanks for watching, this video is actually coming from Allen Academy, which is an online tutoring, private tutoring organization that actually helps students with all of their high school maths and science problems, to help them succeed and all that. So if you're interested in private lessons, you can just send an email to the link in the description. Thanks for watching.